What if the Earth suddenly stopped spinning? Can you imagine what would happen? Get ready, because reality would be far more chaotic than any science fiction movie. In the blink of an eye, anything not attached to solid rock would be hurled eastward at supersonic speeds of over 1,600 kilometers per hour. People, buildings, trees, oceans, ... Everything would be swept from the surface, creating a global tsunami of biblical proportions and winds stronger than any hurricane ever recorded. It would be absolute chaos. For just an instant, the atmosphere would continue to rotate, creating winds that would erode the planet's surface. The oceans, driven by inertia, would flood entire continents. The friction generated by this cataclysmic event would heat the Earth's surface to extreme temperatures, setting everything that remained ablaze. After this initial apocalypse, the planet would be unrecognizable. One side would permanently face the sun, transforming into a scorching desert with temperatures capable of melting lead. The other side would plunge into eternal night, freezing under unimaginable cold. Life as we know it would be instantly extinguished. The magnetic field, generated by the rotation of the Earth's core, would disappear, leaving us completely vulnerable to deadly solar radiation. It would be the end of everything. Now, let's explore another equally frightening scenario. What if the moon disappeared? Our celestial companion is much more than a beautiful light in the night sky. Its gravity is responsible for the tides. Without it, tides would decrease drastically, by about 2/3, altering coastal ecosystems worldwide and impacting marine life that depends on this ebb and flow. But the biggest problem would be the stability of our planet. The moon acts as a gravitational anchor, keeping the tilt of the Earth's axis stable at about 23.5 degrees. It is this tilt that gives us the seasons. Without the moon, Earth's axis would begin to wobble chaotically over thousands of years. We could have extreme tilts, where the poles would receive direct sunlight, melting the polar ice caps and drastically raising sea levels. Or we could remain on one side, with one hemisphere living in perpetual summer and the other in endless winter. Climate change would be unpredictable and violent, making long-term survival extremely difficult. The nights would be much darker, affecting the behavior of countless nocturnal animals that depend on moonlight to hunt and navigate. The absence of the moon would be a slow, but inevitable, death sentence for the stability of our climate. Let's raise the bar. What if the sun suddenly went out? We're not talking about it becoming a red giant in billions of years, but simply turn it off. The first thing we would notice, or rather, not notice, would be the darkness. It would take about 8 minutes and 20 seconds for the last sunlight to reach us. From then on, we would plunge into total and perpetual darkness. Photosynthesis would stop immediately, which would mean the collapse of almost all food chains on Earth. The plants would die within days or weeks. The herbivores would starve to death, followed by the carnivores. The global temperature would begin to drop drastically. In 1 week, the average surface temperature would be 0 degrees Celsius. Within a year, it would drop to around 100 degrees below zero. The oceans would freeze on the surface, forming a thick layer of ice that, interestingly, could isolate the deeper waters, allowing some microbial life to survive near hydrothermal vents on the ocean floor. Humanity, our only hope would be to live underground, using geothermal or nuclear energy. But without the sun's gravity to keep us in orbit, Earth would be flung into interstellar space, becoming an orphan planet wandering through the cold darkness of the galaxy. But without the sun's gravity to keep us in orbit, Earth would be floating into interstellar space, becoming an orphan planet wandering through the cold darkness of the galaxy. It may seem small, but don't be fooled. It's the size that matters. If this black hole had the mass of, say, an asteroid, the effects would be localized, but devastating. It would pierce the planet like a bullet, sucking up matter along its path and releasing an immense amount of radiation. It would leave a trail of destruction, causing earthquakes and massive volcanic eruptions as it passed through the Earth's interior. Now, what if this black hole, the size of a coin, had the mass of the Earth itself? Well, that's a different story. The entire planet would begin to be sucked into it. It would be a process called spaghettification. The gravitational force on the part of the planet closest to the black hole would be so much stronger than on the farthest part that the Earth would be stretched and torn apart. Matter would be heated to incredible temperatures as it fell into the black hole, emitting intense radiation before disappearing forever. Within hours, our beautiful blue planet would be reduced to a bright accretion disk swirling around a point of infinite darkness. The end would be swift, violent, and absolute. There would be no escape. Let's think about something that comes from deep space. What if we were hit by a gamma ray burst? These are the most energetic explosions in the universe, usually caused by the collision of neutron stars or the collapse of massive stars. If one of these explosions were to happen in our galaxy and be pointed directly at us, the consequences would be catastrophic. We wouldn't see anything coming. Gamma rays travel at the speed of light. In an instant, our atmosphere would be bombarded with high-energy radiation. The side of the Earth facing the explosion would be the first to suffer. The radiation would destroy a significant portion of our ozone layer in a matter of seconds. Without this vital protection, the sun's deadly ultraviolet radiation would flood the surface. causing widespread damage to the DNA of plants, animals, and humans. This would lead to a mass extinction, especially of marine life and plankton, which are the base of the oceanic food chain. Gamma radiation would also ionize nitrogen and oxygen in the atmosphere, creating nitrogen oxides that would form a brownish haze, blocking sunlight and causing rapid global cooling, a cosmic nuclear winter. The combination of ozone layer destruction and sudden climate change would be a devastating double blow to life on Earth. Finally, let's imagine that the Earth doubled in size but maintained the same mass. What would change? Our planet would be much less dense. The first and most noticeable change would be gravity. With twice the radius, the force of gravity on the surface would be only a quarter of what it is now. We would be able to jump 4 times higher and feel incredibly light. Carrying heavy objects would be very easy, but this reduced gravity would have drastic consequences. Our atmosphere, less bound to the planet, would begin to escape into space. Over time, air pressure would decrease, making breathing difficult, if not impossible. The water would also boil at a much lower temperature. The mountains, which are supported by the force of the planet, could begin to crumble under their own reduced weight. But the biggest problem would be the Earth's core. With the same mass spread over a larger volume, the core would cool much more quickly. A cold solid core would mean the end of our magnetic field, our protection against solar radiation. Without it, the remaining atmosphere would be swept away by the solar wind, and the surface would be sterilized. Earth would become a rocky, lifeless desert, similar to Mars, but much larger. These scenarios show how our planet is a delicate and interconnected system, floating in a universe that is both beautiful and incredibly hostile. Each element plays a crucial role in our existence. Exploring these what-ifs isn't meant to instill fear, but rather to give us a deeper perspective and a renewed appreciation for our home. It makes us realize how lucky we are to live in such a stable and welcoming world. Each sunrise, each high tide, each season is a testament to this cosmic balance.